Hello dear students of plus 2 medical, non-medical and their respected teachers. So today I am going to discuss a very important topic, electric potential and potential difference and relations for them. So first of all, let us define electric potential. Suppose we have a given charge Q and we know that in the region or space surrounding this given charge there exists an electric field or electrostatic forces applicable on a positive test charge Q naught in the region of electric field of given charge Q. So this means electric field or force will act like this. It means work has to be done in order to move the test charge Q naught in the electric field. Now suppose Q naught lies at infinity and then amount of work done in bringing a unit charge from infinity to the given point is known as electric potential at that point. So electric potential at a point in an electric field is defined as the amount of work done in bringing a unit positive test charge from infinity to the given point. So V is given by W upon Q naught. This is first expression. It means if work done is equal to 1 joule, charge is equal to 1 coulomb, then V will be 1 volt. That is 1 joule per coulomb. So volt is a unit of electric potential in SA system. So electric potential is said to be 1 volt if 1 joule of work is done in bringing a charge of 1 coulomb from infinity to the given point. Then what is potential difference between 2 points? Now instead of point at infinity, suppose we have 2 points, say point A, point B in the region of electric field due to charge Q. Then suppose we have to move Q naught from point A to point B. Then amount of work done in moving a unit positive test charge from point A to point B. So work done per unit test charge from point A to B is known as potential difference between 2 points. So potential difference between 2 points that is W, that is VB minus VA. Suppose VB the potential at B, B the potential at A. Potential difference is given by WAB upon Q naught. This is expression for more general expression for potential difference between 2 points. So potential difference between 2 points is defined as the amount of work done in moving a unit charge from one point to another point. Also, this potential difference between 2 points may also be defined as the line integral of electric field between 2 points. The definition in another way, that is line integral of electric field between 2 points, dl the displacement vector in the direction of electric field, or E dot dl, or there will be some angle between E and dl. So potential difference between 2 points A and B may also be defined as the line integral of electric field E dot dl between 2 points A and B. Now suppose we have 2 points A and B and we move the charge from A to B, then B to A through a closed path. This is first path, this is second path. Then we'll prove amount of work done, that is line integral of electric field between 2 points over a closed path is always 0. That is, we have to prove E dot dl is 0 over a closed path. Line integral of electric field over a closed path is always 0. It can be proved, very easy. Now, let me go from A to B. Then E dot dl from A to B by definition is equal to B minus BA. And when we go from B to A through path, another path, say second path, this is the first path, to second path, so B to A, E dot dl, it will be BA minus BB. And if we add them, A to B, E dot dl, plus B to A, E dot dl is equal to BB minus BA plus BA minus BB 0. This implies A to B plus B to A line integral of E dot dl, that is closed line integral of E dot dl is always 0. It means work done in moving a test charge over a closed path is 0. It depends only upon initial and final positions A and B. So, such a field for which line integral of electric field is 0, that's why electric field is known as conservative field. So, such a field for which its line integral over a closed path is 0 is said to be conservative. So, therefore, electric field is a conservative field, and hence electrostatic force is also a conservative force. So, conservative means amount of work done is independent of the path followed. It depends only upon initial locations of the given points. Then we derive expression for potential difference and potentiality point simply. Very easy. Now suppose we have two points A and B. At a distance of RB and RA. Distance of point A from charge Q is RA, point B from charge Q is RB. Let a point P in between A and B. Then put Q naught test charge at point P. Then electric field at P will be in this direction. So there will be electric field due to charge Q. And suppose we move this test charge Q naught from P to Q through small displacement dr. Get a dr or dl. Then angle between E and dr will be 180 degree. Because to find expression for potential difference, we have to find total work done in moving a unit positive test charge from point A to point B. And for that, we have taken a point P at distance R from test charge Q. Points A and B distances are RB and RA. Then, when this test charge Q naught is moved from P to Q through small displacement dr, that small amount of work done is given by F dot dr by definition of work done, or it is given by Q naught E because F is equal to Q naught E dot dr, or total work done in moving from A to B is given by line integral of electric field from A to B by definition, or it is given by Q naught minus EDR. Why minus EDR? Because A dot B is equal to AB cos theta. Cos theta in this case is 180 degree. So cos 180 is minus 1. So limits will be RA to RB, because we are integrating with respect to R. So take limits with respect to from RA to RB. Or WAB is equal to minus Q naught. Now what is E? Electric field due to single point charge. We have discussed in chapter of electric field. So it will be 1 upon 4 pi epsilon naught Q by R square. E the electric field at P, which is at distance R from Q. So electric field due to single point charge is given by 1 upon 4 pi epsilon naught Q by R square. Or work done, WAB comes out to be minus Q naught upon 4 pi epsilon naught integral RA to RB, so R minus 2 dr. So solving this integration, we have WAB per unit test charge Q naught minus Q upon 4 pi epsilon naught integral of R minus 2. It will be R minus 2 plus 1 upon minus 2 plus 1, limits RA to RB. So if simplify, minus 2 plus 1 is minus 1, so minus 1 is plus. So work done per unit test charge between 2 points A and B is given by Q upon 4 pi epsilon naught 1 by R, limits RA to R. Simplifying it, so we have WAB over Q naught Q upon 4 pi epsilon naught, put R is equal to upper limit RB 1 upon RB minus 1 upon RA, which is nothing but BB minus BA. So potential difference between 2 points. So which is required expression for potential difference between 2 points. So BB minus BA is given by Q upon 4 pi epsilon naught R, epsilon naught 1 by RB minus 1 upon RA. The required expression for potential difference between 2 points. It means potential difference between 2 points depends only upon RA and RB, initial locations of the points. In other words, amount of work done in moving a test charge between 2 points depends only upon the initial locations of 2 points A and B, that is RA and RB. So that's why electrostatic force is said to be conservative force if this property is satisfied. Now, similarly, if you have to drive the expression for potential at a point, you can start from this, you can take point A at infinity. No change, everything same, you have to take infinity to point P. So limits will be from infinity to R. You can drive the same expression, or as a special case, when A lies at infinity, the VA will be A lies at infinity, VA will be 0. When A at infinity, because if we have to find work done in moving a unit positive test charge from infinity to the given point, that is potential at a point, then VB will be equal to V say and when V lies at distance R, so then V minus 0 will be equal to Q upon 4 pi epsilon naught 1 by R minus 1 by infinity, that is 0. So V comes out to be 1 upon Q upon 4 pi epsilon naught R. It is V is inversely proportional to R. So this gives the expression for potential at a point. So electric potential due to a point charge is given by 1 upon 4 pi epsilon naught Q upon R. Just electric field due to single point charge given by 1 upon 4 pi epsilon naught Q upon R square. Electric field is 1 upon 4 pi epsilon naught Q upon R only. So this gives expression for electric potential and electric field between two electric potential and electric potential difference between 2 points. Now let us find expression for electric potential due to a number of point charges. Potential due to a number of point charges. Number of point charges. Suppose we have n charges Q1, Q2, Q3 and Qn at location R1, R2 and R3 and Rn. This is the observation point where we have to find electric potential due to all these n charges. Then by definition V1 will be equal to 1 upon 4 pi epsilon naught Q1 upon R1. Similarly V2 will be equal to 1 upon 4 pi epsilon naught Q2 upon R2, so on and so on. Vn will be equal to 1 upon 4 pi epsilon naught Q upon Qn upon Rn. Total electric potential will be sum of all these individual potentials. So total electric potential at point P is given by V is equal to V1 plus V2 plus so on plus Vn, or V is equal to Q is common, 1 upon 4 pi epsilon naught is common, Q1 upon R1 plus Q2 upon R2 plus so on plus Qn upon Rn, or V is equal to 1 over 4 pi epsilon naught summation I is equal to 1 to n Qi upon Rn. So which is the required expression for electric potential due to a number of point charges. So this is all about electric potential, potential difference, definitions of both. Then we have calculated electric field due to a line integral of electric field over a closed path, which proves that electric field as well as electrostatic force is a conservative force. And number 2, we have derived expression for potential difference between 2 points and electric potential at a point. Also we have calculated electric potential due to a number of point charges. In the next video, I will discuss electric potential due to a dipole at a point on axial line and equatorial line. Also, we will obtain expression between electric field and electric potential. So, dear students, ਜੇ ਤੁਹਾਨੂੰ ਇਹ ਮਾਈ ਵੇ ਆਫ ਟੀਚਿੰਗ ਵਧੀਆ ਲੱਗਦਾ ਹੈ, ਮੈਂ ਮਿਹਨਤ ਕਰ ਰਿਹਾ ਤਾਂ ਕੋਸ਼ਿਸ਼ ਕਰੋ ਲਗਾਤਾਰ ਮੇਰੇ ਨਾਲ ਜੁੜਨ ਦੀ। ਇਹਦੇ ਵੀਡੀਓਜ਼ ਨੂੰ ਬਾਰ-ਬਾਰ ਦੇਖੋ ਔਰ ਤੁਹਾਨੂੰ ਸਾਰਾ ਕੁਝ ਕਲੀਅਰ ਹੋ ਜਾਊਗਾ। ਸੋ ਫਿਜ਼ਿਕਸ ਸਿੰਪਲ ਹੈ, ਇਹਨੂੰ ਇੰਜੋਏ ਕਰੋ, ਇਹ ਤੋਂ ਡਰਨਾ ਨਹੀਂ। ਸੋ ਇਹਨੂੰ ਇੰਜੋਏ ਕਰਦੇ ਹੋਏ ਜੇ ਪੜੋਗੇ ਤਾਂ ਤੁਹਾਨੂੰ ਬਿਲਕੁਲ ਜਲਦੀ ਸਮਝ ਆਊਗਾ। ਸੋ ਨੈਕਸਟ ਵੀਡੀਓ ਤੱਕ खुश रहो, इंजॉय करो और फिजिक्स ਨੂੰ ਦੱਬ ਕੇ ਪੜੋ। थैंक यू, ऑल द बेस्ट।